In this lesson, we're going to review the net present value formula. The net present value formula is used to determine the present value of future cash flows on an investment and thereby how much money it will return over the term for decision-making purposes. The term may be a year in length, 5 years in length, 10 years in length. That really depends on the project. Let's take a closer look at the formula in greater detail. The net present value formula is comprised of a rate syntax and the value syntax. The rate is the discount rate to be used in the calculation to discount future cash flows. The value is the amount of cash flows that will be returned by the investment over the investment period. Using simple math, let's understand how the NPV formula works. So as you can see in row 17, NPV is equal to the negative amount of initial cash outflows, i.e. the money that you're spending on the project. Then you add the sum of the discounted future cash flows to take into consideration the time value of money and other factors. So the NPV is equal to the negative amount of cash outflows plus the cash inflow on year one divided by 1 plus the discount rate, and then you add in year two and so on. So you'd add for year two the cash inflow for year two, divide that by 1 plus the discount rate, and so on, depending on the number of years of future cash inflows the project will yield. Let's take a look at an example on how we can apply the net present value formula within Excel. An investment firm is contemplating investing in a high-tech company with its capital of $120,000. Profits for the next 5 years are expected to be the below amounts as shown in the table in cells D27 through D38. It wants a return of 1% per month, and therefore this should be used as the discount rate. What is the net present value? In the table summarized on screen here, we have the month shown in column C and the amount of undiscounted future cash flows shown in column D. The discount rate is 1% as indicated in cell D24. The upfront cost is $120,000 and we put that in cell D41. So in order to calculate the net present value of future cash flows, we can do that in cell D46. So in order to calculate the amount of undiscounted future cash flows and determine the net present value, we do that in cell D46. So if we were to open up cell D46, we can see that we use the NPV formula and then open parentheses, we use D24 for the rate, which is 1% in cell D24. And then for the value, we highlight the amounts of undiscounted future cash flows which exist in D27 through D38, which is months 1 through 12 of the return. And then we add in the upfront cost, which when we're adding it is really subtracting it because it's already a negative value of $120,000. When we press enter, we can see that the net present value of this investment is $161,377. And that's what it's going to yield over the course of the 12-month period. Another way to look at this calculation and do it manually 1 month at a time is to break down the future cash flows. And we can do that and discount each month individually if we wanted to and still achieve the same result, just to prove that the formula is working. So the below table takes the future cash flows of each specific month, which was $25,000 per month, and then it discounts it by the 1%. So we're taking, in the first month, we're taking the month one undiscounted future cash flows of $25,000, dividing that by 1 plus the interest rate of 1%, and we're putting that to the power of 1 for 1 month or 1 period. Then in cell D54, we're calculating that very similarly, but instead of to the power of 1, we're putting that to the power of 2 because 2 months will have lapsed by the time we receive the cash flows for month 2. And if we do that, we can see that the sum of the discounted future cash flows in cell D65 is $281,377. And when we add that to the $120,000 of upfront cost, then we arrive at the $161,000 $24,377 of net present value, which matches the NPV that we previously calculated using the Excel formula for NPV. So that just goes to prove and show that the NPV formula in Excel is reliable, it's accurate, it does work, and it's a much simpler way of calculating the net present value on a project rather than discounting the cash flows per period in the future, one period at a time. Let's illustrate how discounting works so that it's clear how to determine the present value of future cash flows. If each period has a discount rate of 1%, i.e. a 1% return is expected each month, then the value of money received in month 2 is not as valuable as the money received in month 1. Similarly, money received in month 12 is not as valuable as the money that is received in months 1 through 11. The present value of the 1% in month 0 is 1%, but in month 1 it's 0.99%, and in month 12 it's only worth 0.89%. We can see the effect of this in the table shown on screen here, starting in row 75 through 88. We have the months or the periods in column C, the discount rate per period located in column D, and the present value percentage that's included in column E. And what we're doing there is we're taking 1 divided by 1 plus the interest rate of 1% in cell E76. And as we scroll down, we can see the effect of the compounding. We can see in cell E81 that if we take 1 divided by 1 plus the interest rate of 1% and multiply that by the present value percentage, i.e. 95% from the previous period, then it results in a present value percentage of 94%. The present value of 1% by month 12 is 0.89, and that's equal to the discount rate of 1% multiplied by the present value percentage. So as you can see, the money loses value over time, each period gradually, and the present value shrinks. So in month 1, the present value of the $25,000 that we're receiving is worth $24,752.48. By month 12, that's only worth $22,186.23. The sum of the discounted cash flows that we're receiving in months 1 through 12 is $281,376.94. If we were to add that to the upfront cost of the project of $120,000, then again we arrive at $161,377 as the net present value of cash flows on the project. So hopefully now you understand how the net present value and discounting of future cash flows works while taking into consideration the time value of money. The goal is to have a positive NPV while assuming an appropriate discount rate. In this case, it's going to achieve $161,377. So the company can assess whether or not to pursue the project. It is greater than 0, which is a good sign because that takes into consideration the discount rate they want to achieve and the upfront cost of $120K that they have to put into the project to get it going. Hey guys, thanks for watching this lesson. I hope you enjoyed it. And if you did, I'd really appreciate a like and subscribe from you. And if you want to learn more about Microsoft Excel, check out these videos above. And don't forget to check out our website, commercecurve.com, where we have lots of in-depth finance and accounting courses available with full training workbooks. All of our courses come with complete workbooks of lessons, examples, pre-built financial models, and training video. Hope to see you there.